I'm Jim Magee. I'm with Facility Commissioning Group from Lexington, Kentucky, and this is Bob Knoedler. He's with Hanson, and Bob lives in Magee Valley, North Carolina. And we're presenting today on our after-hours commissioning lessons learned in K-12 schools. This qualifies for CES credits and any kind of CEUs you want. And it's obviously copyrighted. We want to talk today about some of the challenges that we've seen and a little bit of a light and whimsical view of commissioning HVAC systems and others in K-12 schools. And we really want to present some of the challenges that we see among the project team members in these types of projects. We want to talk about how the International Energy Code and International Energy Conservation Code is affecting K-12 sector in bidding and procuring and executing commissioning projects, as well as talking about design review and how they're also important on prototype schools in addition to every other type of school. We also want to walk away with an understanding of the integration of controls and the need of verification and coordination with the school system, as well as how to oversee proper startup and verify proper documentation and tab verification on K-12 schools.
So part of what we're going to do today with respect to the overview or the outline, we're going to talk a little bit about the unique character of the client with respect to school districts, K-12 school districts. In addition, we're going to talk about, again, the project delivery methods that we see out there, acceptance and occupancy, and then we're going to talk a little bit about case studies, some of the challenges and issues. Both Jim's firm and our firm have done a lot of K-12 commissioning around the country, and then we're going to end up with kind of a pictorial summary of what we call the Hall of Shame. So you're going to see some very unique and challenging, what I would call surprising and embarrassing pictures at the very end of this. So that's part of the lightheartedness that Jim's talking about. So talking a little bit about planning, design, bid, and award. Again, if you're working with K-12 schools, first of all, you've got a multi-headed client. A lot of districts that are large districts, you've got a capital program or capital planning group, which lays out the various school projects. Then you've got a separate construction management group. A lot of times you have a separate facility management group. And then the principal may come into play, and it's all underneath the Board of Education. So you're dealing with really a large, quote-unquote, client group that you've got to satisfy and that you've got to coordinate with. The other thing is that most school projects, as you may know, they try to hit and schedule for delivery either in August, right before the school year, or between semesters, right between any kind of a break. Finally, you've got the situation where a lot of school districts, with respect to additions, renovations, modifications, are very aggressive in their scheduling. So you've got to work with them. They have to fully understand that they can't be too aggressive in developing the scope for their work. It's very, very important that there's contingencies that are developed. What if the project doesn't get done? How do you accommodate, students if the facility isn't ready, if meals aren't going to be prepared in that particular kitchen or cafeteria, or finally, if there's activities that can't be done because the project didn't get complete. So those are all challenges that we see out there. In addition to that, we have a client that oftentimes, in order to try to meet the schedule, will look to pre-purchase equipment, and he may do that for several reasons. Number one, for tax-exempt status. Number two, because he's looking for compatibility with existing systems or existing equipment, both at that school or other schools. And thirdly, he may do it just to ensure that the equipment is on site, ready for the contractor. So we've got to deal with that aspect of it. He may want to engage for a service maintenance contract. One of the things with a school district is that you've got to look at level of authority and level of responsibility. As I mentioned, if there's a multi-headed client, okay, then with respect to change orders, who's got the authority to authorize those, during the course of the project? And if they have to go to the school board, the Board of Education, that group probably only meets once a month. So in order to keep the project going, there's got to be some level of authority at the project manager level or somewhere within that construction management department to allow the contractor to keep moving. So again, there's a lot of challenges, and finally talking about maintenance training, and Jim's going to talk a little bit more in detail about that, but it's absolutely imperative, and you're going to see this at the very end of our presentation today, that if you've got a big district and their concept of maintenance and operations is to have regional groups that basically rove around the various schools, you better have somebody at that school that knows how to deal with emergencies if they happen, okay? So the training may not just be the facility management group, it may be people on site that can deal with emergencies, and like I said, you'll see a video at the end.
We deal a lot too with IT issues on projects where the school board is responsible for installing network connections or bringing in phone lines and things like that. These are issues that have to be dealt with up front or they become big scheduling problems on this kind of a project. The other thing we want to talk about is the fact that renovations and additions are a special kind of project. And a majority of school projects, in addition to being short time frame, tend to be renovation and addition projects. So we have to deal with issues like occupant wayfinding, how to segregate the construction area, and controlling noise interruptions, which don't on the surface sound like commissioning issues, but they impact everything we do and the way we have to schedule, and we are really advocating for the owner, so safety is always paramount to the way we deliver our services. So we need to schedule construction carefully up front and understand the school schedule, the holidays that are in play, and exactly what the other activities are that occur in and around the school in order to appropriately see the construction manager schedule the work properly and us to get our sequence in as well. Integration of new and existing equipment with existing utilities and existing infrastructure is a huge challenge that you don't face on every project, but it's a big deal on a renovation addition, and particularly when it's in a school project. And then we're constantly dealing with outdated versions of software for whichever type of equipment we're integrating with, and whether or not we need to bring the existing platform up to speed. And these are just some of the issues that we look at in renovation. Design also impacted importantly, and when we're in a design phase and we're working with the design team, number one priority is, are we being too aggressive and oversizing the scope of the project? I mean, if you're working with 2 months, what's realistic? How can you install in 2 months and order equipment in 2 months, for example? And then the other thing is how service maintenance contracts and O&M staff considerations play into the design. We design too many schools these days where we turn them over to owner-operators who have really no training and ability to operate and maintain the systems. So certain types of systems like VRF, HVAC systems, for example, it's encouraging to the owner to procure service maintenance agreements to properly maintain equipment, and we need to support the owner, make sure they're understanding how to negotiate those deals and sign appropriate contracts for their work. Third-party vendors that are owner procured, it's a commissioning responsibility to help integrate. And a lot of school systems have gone to procuring their own test and balance. In that case, you got to make sure they show up with appropriate documents and that they're integrated properly. And bottom line is we need a very robust OPR to do a quick-paced school job so everybody knows where they're at, what the systems are, and where we're going to take those systems. The delivery mechanism, are you doing design spec build, or are you doing construction manager at risk? The procurement and the need to ask for permission from the school board and other design and other entities is a factor in how complex your design is and the small time you have it. We also want to see closeout provisions interlocked with HVAC, FPT, acceptance phase compliance. And it's a way to not pay the contractors and keep them interested on the project if they haven't completed the scope of work, which should include commissioning because the system doesn't operate properly until it's commissioned. So an owner hasn't received beneficial use of anything until it's operated, so why pay them? Sustainability goals and practical applications is an issue we face frequently on school projects where we're designing in order to meet LEED compliance and we're not designing in order to meet the school system's mission and the owner's project requirements. So we want to KISS. That's really the basic thing that we want to do on school projects whenever possible. And that's really the direction we want to lead construction administration as well as construction management. Prototype designs, Bob is very, very nitpicky on the fact that you can't not review a prototype design. Just because you've built the same thing previously doesn't mean you don't have a unique set of factors that you got to take into account. And design review is even more important on a project that has a compressed construction schedule. So design review, submittal review, they become more timeline critical and also more critical to the project overall. I like how Bob says that in order to do an appropriate commissioning design review, what you want to do is design. Can it be designed? Can it be constructed? Can it be balanced, controlled, operated, adjusted, tested, and maintained? And that's really a good synopsis of what you'd be looking for on a design review.
So, to follow up with Jim's comment about prototype, I can't count the number of times that we've design reviewed a prototypical school, and many times ones that we've seen before, multiple times, and we still see the same coordination issues. We still see the same problems. It kind of boggles the mind that once errors and omissions have been identified in a set of documents that are going to be reused multiple times, that are not corrected by the AE. That's why, even though we hear about prototypical designs, we review every single one. So one of the things driving that we've seen recently, again, commissioning, we're seeing more and more school districts, more and more school boards moving towards commissioning. And again, one of the reasons for that is the integration and incorporation of commissioning into various codes. Case in point is one that we're dealing with right now, that the local authority having jurisdiction adopted the 2015 International Energy Conservation Code. And when you look at that code, you really see commissioning starts and ends, it's got to be all the way through that project. Because again, the requirement for a commissioning plan to be developed at the time of permitting is one of the requirements to be developed by a registered design professional, or as they say, an approved agency. So up front, the commissioning authority has to be engaged and has to be a part of the project. It talks about the various systems, which again, mechanical, electrical, lighting and controls, service water, and then any renewable energy systems. And then it's got very specific requirements as far as system balancing, functional testing, et cetera. But one of the keys, again, is the requirement that the building by the authority having jurisdiction, and we actually have a local authority that has been very specific about this, they're not going to consider final inspection until they receive a letter from the building owner that he's received a preliminary final commissioning report. So again, commissioning can influence occupancy. So we talk about the importance of getting commissioning done, okay? It's going to influence occupancy if you've got a local authority having jurisdiction that's abiding by the 2015 code.
It's a paradigm shift when you have commissioning attached to permitting of construction and to certificate of occupancy issuing.
So what's really important, and whether it's tied to the energy code or whether it's tied to standards and guidelines that are adopted by the school district, is that the commissioning authority has to get engaged early in the construction process. So he needs to participate in the pre-bid meetings, in the pre-construction meetings. He has to make it crystal clear to the contractors, the subcontractors, everybody, what their roles and responsibilities are with respect to documentation, with respect to support. There also has to be, from the owner's standpoint, he's got to explain what are the constraints if this project goes over schedule. And I can tell you that they will move into that school. If they need that school, they will move into that school in August, September, whenever school starts, or in January. And you will be doing your testing after school, at night, on weekends, whatever it takes. That's just the nature of the beast. So that's got to be crystal clear. It's crystal clear to us because we've done it so many times, but also to the contractors because we need their support. So if that controls contractor has to be with us at night or on weekends, that's the way it is for functional testing.
So we'll talk a little bit about construction management, not that we intend to do any of it, but specifically that we need to advocate for the owner and make sure we get out of management on the project what we can. But renovation and addition projects, particularly as well as school projects, it's such a fast-paced situation. We need accurate estimates. We need constructability analysis. We need to have value engineering not impact the owner's project requirements. There's a lot to do. There's project coordination, site logistics and planning. I mean, there's a lot of work that has to be covered. And if you're not seeing plans and hearing discussions from the construction manager, they're planning to do what they want to do until the owner steps in and actually controls the situation. So part of advocating for your building owner is advocating for your construction manager to do their job appropriately. This really speaks to the fact that bid package development and your participation in design phase on a fast-paced K-12 project is really paramount to succeeding on the project. On-site staff project. I mean, if you've worked with people before, it helps, and knowing people who have experience in K through 12 schools and renovations is a big plus, because you have to manage the trade contractors tightly, and you're going to have a lot of people in confined spaces. So these are very dangerous projects. And safety to us is paramount, both in our commissioning services and in advocating for the owner to make sure that they're having a safe job underway. And then implementing quality control and maintaining time and material delivers is all just high-paced stuff. At the point of getting past the installation, we need to do startup and commissioning. These are all things that need to be done after construction is complete. So what happens is they take all the time up on construction, and then we have to try to figure out how to fit these things in. Okay, so let's talk schedule every time we sit down and meet with everybody. Startup commissioning, punch list inspection, fire marshal, AHJs of all types, building, mechanical, electrical inspectors. We have to get an O&M deliverable. We have to do training. We have as-built drawings to review. Special documentation for different kinds of testing, such as a geothermal well field testing, things like that. And then Bob will talk a little bit about how important it is on doing near-end of warranty work. Submittal review process, it has to happen, pop, pop, pop. We really advocate for owners to work with their design team and maybe bring on a construction manager early and order equipment. Get the submittal process and equipment order out before the construction schedule starts. The biggest hang-up on a K through 12 job in the summertime is waiting for the rooftop units to show up or whatever equipment it is you're missing. Design team and commissioning authority engagement is critical. We got to talk and work and think on our feet when we're working a K through 12 project, because there's just so many complications that come up. And warranty requirements are really important to make sure we understand on these projects that they may not be completed in a consistent period of time. And some things may be left behind because time runs out. It's very important for us to keep track of when the warranty dates start and begin and when things are actually officially accepted so that we can cash in on the warranty value for the owner.
You know, just to follow up with Jim on the submittal reviews, again, if the equipment's being pre-purchased, we got to make sure that the owner has included in there any startup, any training, anything like that that is typically required within the specs for the contractor to do. But we've got to make sure if he's purchasing this equipment, because the contractor's not going to provide it, all right? If they're just going to receive the equipment and install it. So communication, talking a little bit about that, obviously probably the two key areas of commissioning are communication and documentation, okay? So this is a list, you can look at the bullets there that are important, you know, whether you're doing meetings, whether you're doing site visits, maintaining your issues log, coordinating with the contractor for schedules, witnessing or representative witnessing some of the field testing, directing the functional testing, et cetera. That's all really critical in terms of communication. But the other thing is to communicate with the owner and the AE with respect to payroll request. One of the things that we are vehement about is that as they're reviewing the progress of the contractor throughout the project, month by month, that they take a look at how the contractor's maintaining his commissioning documentation and is living up to his responsibilities. If that's not being maintained, if he's not completing his checklist, if that work's not being maintained, we're asking the AE to say, look, you need to catch up with that or we're not going to approve the pay request. We think it's as important as any other aspect of the project, okay?
And there's a lot fewer payroll requests and invoices on a fast project, so money gets spent very fast. So if you don't get a handle on invoicing right off the bat, you can miss out on the ability to really make the contractors interested in what you're doing.
So the other, another aspect is again, quality control. And we view commissioning as a risk management exercise dealing with quality control, quality assurance. And these, again, are a number of bullets of the things that we look at in terms of pre-installation meetings, installation tests, mock-up wall if you're doing envelope commissioning. And you can see the checklist, the startup tests, et cetera, functional testing. This is all absolutely critical, and it's part of the process that we as a commissioning authority lead, but it absolutely takes the participation of everybody else on the team, contractors, subcontractors, and we really need the owner's buy-in. And we've been successful with a number of school districts as they've seen the value of commissioning to really get their project managers engaged to make sure that all of this happens. all the way through the process.
Put up these deliverables and then knock them out. That's exactly right. And one of the big issues that we have on K-12 projects is water quality for the HVAC systems or other systems. And again, a renovation project, a lot of times we've already got existing piping. So we need to make sure we got a handle on how we're going to separate the two systems, how we're going to flush, fill, and clean and treat the systems, and at what point is the new system complete, and what is the verification on the other side. We don't want to just hook up a brand new clean hydronic system and connect it into a filthy existing system. So it's very important to specify and work with the designer early on to make sure we put flush, fill, and treat, or make sure that they have a validated chemical treatment plan in place so that we can cross-connect our new and renovated systems with the existing systems. And there is so much trouble that comes out of these systems, and we all know, because we can either get, a chloride imbalance, or we can get pH off, and it's just a ton of problems. And back flushing strainers and making sure that we don't have clogged strainers so we don't get intermittent failures on heat pumps and so forth. We all know. Chain of custody on water treatment, there was a big responsibility on these K-12 problems. So what happens is you do all this correctly, and then you never really think about the fact that the owner's going to take the system over, and then he's going to have to hire the chemical treatment factory. So how do we help the owner and the contractor transition from the warranty phase chemical treatment to them contracting it and maintaining their own hydronic systems? Critical on these projects. And the thing about hydronic flush and fill is you can miss it, because the project happens so fast, the contractor wants to whip through that, and it happens way before you're really doing a lot of rough-in and other stuff, or at least final installations.
As kind of a follow-up to Jim, is we actually have one school district we work for where actually now we have a meeting with respect to flushing the systems, cleaning and flushing the systems, because they've had so many issues with the contractors. And we had contractors that would bypass the coil, but they would do it right at the coil, and they wouldn't bypass the control valve or the valves before it. So we've actually developed a standard that the district has accepted that is actually in the specifications, and we actually meet with the contractor prior to them doing the work. It's kind of like that pre-installation meeting that we talked about.
Flushing through coils is bad. We see that a lot too. Absolutely.
So one of the things we talked about quality control, again, the pressure that we get, again, because of the schedules to get the schools on board, to go out and do the testing when the contractors haven't really completed their work in terms of the checklist, et cetera. Now, you may not be able to read this, but for example, you can see the red versus the black. This is a detail of a layout and the configuration for water heater piping. And everything you see there to the right in the box that says not included points to a valve, a meter, a gauge, a section of bypass piping that was all omitted on a project and was caught by our commissioning specialist as he was out there in the field. It was never installed. Well, we're not going to do any testing until this is right, until this is corrected. So again, the importance of that upfront check before you move into testing is absolutely critical. Another thing is integration of building automation systems, the building controls with the OEM or the prepackaged controls from the manufacturer. This is also probably our biggest headache, and the thing that we've tackled by having and requiring 2 meetings on every project. We do one, we call them controls integration and interoperability meetings. We do one during design. We sit down with the engineer of record. We go through what we call a contractor responsibility matrix. Who's responsible for furnishing the controls, installing the controls, and then providing the integration? It's absolutely critical. The second meeting we have is after we receive and review the contractor's shop drawings, control shop drawings. And this has saved us a lot of time, a lot of headache. It's absolutely critical in this day and age when you've got so many prepackaged controls that you work with them in terms of communication protocols, and you get everything up front in the specs, and then make sure that the contractor has echoed that back in his control drawings. It's really very, very important.
So in terms of occupancy and acceptance, I think the single most important thing to a successful commissioning project is the O&M turnover. And on a school project, I don't know where there's a more difficult client to actually turn over projects to in a lot of cases. So, it's not any different than the normal process that we operate. It just takes more intensity in terms of our approach to it. And what I'm trying to say is that, you may or may not be in contact with all the people you need to train or you need to communicate with. It's not sufficient just to deal with a superintendent or a principal of a school or their construction management team. You've got to really introduce yourself to these school system operation and maintenance people, their facilities department. Find out who's in charge, so when it comes time to train, you're training the right people, because I think the biggest thing that happens in school projects is they're in a big hurry. You sometimes train the top few people in the PPD, and the thought is that they'll pass that down the chain, and it just never happens. So we really want to know, how do we train shift workers? How do you operate your systems? Are you using service maintenance contractors to deliver train, and then we need to deliver training to them if that's the case. And then the audio-video recording is really important, because as soon as the school system trains these guys up, someone's going to hire them, and then we got to train somebody else. So, you know, we're really looking at the intensity of training to match the complexity of the system as well, because sometimes you really have to start at a more fundamental level to train school staff on how to operate VRV and more complex systems, and that's where you really get into helping them to realize they may need service maintenance plans and that type of stuff. You don't get there if you're not having dialogue with the operation and maintenance personnel. And then always have sign-in sheets when you do training or anything. Hands-on too. I mean, I think you should have about a 50-50 thing. You should have handed out materials so that there's takeaway from the training beyond just in O&M manuals. And then I believe you should spend at least half your time out in the field, hands-on, touching equipment. Make sure everybody understands the description of the system. You know, start with a broad description and work yourself down into components. Startup, operation, shutdown, emergency, and maintenance are all procedures that they need to be trained on. Sometimes I see someone training on a little standalone water heater or something like that, and the training lasts 10 minutes. Can you cover that in 10 minutes? I mean, it's hard to even read this in 10 minutes. So, and also make sure that they understand what kind of spare parts are available to them and tools that are available to them. Do they need the water meter that was used to set up the job in order to operate and maintain it, for example? And lots of other devices that you might need with lighting controls and programming interfaces and things like that. So they won't know what's being given to them in the project unless they are told that at training, because you know your typical O&M guy's not going to bore down into the spec book to figure this out.
And you may want to remember bullet 5, emergency procedures, again, based on something we're going to show you at the very end.
Oh, Bob's going to tease. And then the warranty is basically important to make sure more than anything that the warranty is applied at the appropriate point in the project. I really advocate no warranty until the owner's beneficially using the systems. I mean, that's really the bottom line where you should see. Now, the owner can overrule you, obviously, for whatever reasons they have. But when you cite that in a construction meeting or in design review meetings, it's usually pretty well received. No final payment till the job's closed out. We got to make sure that we're retaining whatever resources are available to do off-season mode and off-season mode testing and training. And we also want to make sure that there is, if there should be, an energy baseline or an energy model that needs to be calibrated, and we need to set up with the contractors or the owners or the designers how it is they intend to calibrate their model. And we advise owners to really compare the operation of their facilities to listed published data such as CBEX data to see how their building's performing. And then off-season testing and verification is very important. It's very important to see what your systems look like after they've had an opportunity to run for 9 or 10 months. You know, are they being maintained properly, or are they just neglecting cartridge filters and letting your systems get dirty and loaded up? I mean, you can help the school system if you can catch poor operation and maintenance procedures on new or renovated facilities before they get too degraded to be recovered. You know, and it doesn't take a lot, you know, to throw away some pretty good equipment if you're not careful. Winterization is a key component because we lose so much equipment to freezing and other radical things if you're in that type of an environment. Preventative maintenance questions and PM schedules need to be discussed in off-season mode. What we like to do is you may have like a specialty piece of equipment that the owners, people have never used before. So the first PM activity, let's schedule to do that with the contractor, you know, and it might be something that needs to be done within the warranty anyway. So, you know, help them do that first installation. If equipment's not working, chronically failing, never been installed, extended warranties are in order, and they're not going to be provided unless they're fought for. So what we really do is when we train and we turn the systems over to the owners, we want them to understand that their operators need to continuously evaluate the performance of their system so that we can be aware when things aren't operating properly. And we give them tons of tools to do that with in terms of, you know, DDC controls and BAS systems and everything else that we're doing today. When you're done, we want to trend the systems. We'll make sure all the scheduling and so forth is right when we're coming back in the off season. And then all these types of equipment, if they're not in their full load condition when you finish your project, you really need to schedule to come back and test. I mean, you can certainly work out situations where you bring in load banks and things like that, but I still think no matter what, you got to look at the system under performance and load conditions. And the only way to do that is off-season load testing. Another thing to keep in mind, and the schools are really going for energy efficiency and installing a lot of VRV, VRF technology in their schools, but in the northern climates, a lot of them are not looking at low ambient temperature setups on these equipments, and then they do fine in the summertime and they end up not being able to heat their facilities. So there's a lot to look out for. Off-season mode training, similar things. We just make sure we do it. Good time to go back and really get into the DDC and the BAS, find out if programming sequences changes. Bob will tell you that sometimes the energy manager will actually change the sequences of operation and screw up your conditions in your building in order to save energy. And that may actually take it out of code compliance. It may make it, we can quote Dick here, Dick Dutro. He likes to say that in their philosophy on commissioning school systems is we'd rather make them sleepy than moldy. So you got to make your compromises where you can in terms of outside air and how you use it. And this is a great time when you're coming back in off season to look at that type of stuff.
So again, near end of warranty review. Again, this is what a lot of people call the 10-month warranty walk down or warranty review. One of the things we like to do is gather as much information as possible before we go out to the site. So, we're taking a look at pulling trends off the BAS system, reviewing any scheduling, any alarms. We're going to talk to the operators. We're going to talk to the people. Have you had any operational issues? Have you had any failures? Is it chronic? We'll review any maintenance logs that they have. One of the other things is, again, if it has an energy manager, take a look at the utility bills, and we'll take a look and compare those against similar type schools, or if they did an energy model on the school, we'll compare to see how it's tracking. One of the things on the second to the bottom bullet, talking about energy management pros and cons, is what Jim was alluding to a second ago, that sometimes there's this disproportionate, you've got an energy manager whose sole purpose for that district is to drive down the EUI for the various schools. And, he will cut back outdoor air, he'll do everything he can to try to save energy, and it may be at the cost of the comfort, of the people within the school. So you've got to be very careful about that. And finally, once we've gathered all that information and it's given us any insight, we will go out, walk the site with the project team, with the operators to say, okay, are there any issues that have to be addressed by the contractor prior to the expiration of his warranty? So moving on, and again, I just talked about the energy manager, and again, he may be at odds, with comfort or with what's going on in school. One of the things that we're starting to see, and we've got one district right now that's very aggressive in this, is districts that are monitoring and tracking the performance of their schools. And by that I mean not merely reviewing their utility bills and keeping them on a spreadsheet. They're actually tying them into energy information systems where they've picked up the meter data and they can actually look at it real time. In addition, they may pick up other points from the BAS systems, and it gives them some insight to how the schools are operating. We absolutely, as a company, and I think as a group, see this as a natural progression for both commissioning authorities and for energy management professionals. This is your ongoing commissioning, your monitoring-based commissioning, your continuous commissioning, whatever term you choose to use. This is where it's going. This is where the collection is. We're seeing it not only on university campuses where we've seen it for several years, we're now seeing it in districts, school districts, K through 12. They see the importance of this.
This is where you can pay for your services too, where
Exactly.
you can make the money that can pay you your services.
So we want to move quickly into some case studies and some of the things that we've seen. And the first one deals with design commissioning, where we have a design engineer that has worked on several projects that we have reviewed. And what's unique about this is he puts a note on his drawings. It says on the VAV schedule that the minimum airflow on his VAV schedule relates to the minimum amount of outdoor air that's supposed to be required through that VAV box. And then he goes on to say, but that may or may not be the required minimum flow through the box. So Mr. Tab contractor and Mr. Controls contractor, you need to determine what the minimum flow needs to be on that box, and you need to make any adjustment to that flow necessary in order to make sure that the boxes work properly. And we have cited this comment numerous times. This gets back to my comment about prototypical schools, and he refuses to remove the comment. But my question is, who's the designer of that system? At the end of the day, is it the tab contractor and the controls contractor? Because they're being told you're responsible for setting the system up and determining what the minimum flow is supposed to be.
This wouldn't fly in my area. My contractors would refuse to make that determination, and they'd ask for a change order. So
Well,
it's really building a change order into your project is all it is.
And that's pretty much what's happened with us as well. So now the controls issue. So here's a situation where we got a packaged chiller with its own pumps, okay? And the design engineer of record had what was essentially a soft freeze protection specified, which meant that if the temperature on his sensor, and that sensor was upstream of the coil, it was within the duct, he says basically if it hit a certain temperature to start the pump and just circulate the water through the coil, okay? Unfortunately, the packaged chiller has its own safety, and it controls the pumps, and it works off of ambient air. So if the ambient air fell below a certain temperature, then it will start the pumps, and it will do its own freeze protection. The BAS has no control of the pumps. So it's a situation where the specified control sequence cannot be implemented unless you somehow coordinate with the manufacturer and compromise his internal safety. So this gets back to those meetings I talked about for controls integration and interoperability. This is another one where we have a designer who loves to use thermal fusers, VAV diffusers, downstream of a VAV box, okay? If you're going to do that, the manufacturer says, well, then you've got to control the box off of static pressure in the downstream duct. That's the only way to do it. Unfortunately, this designer chose to control the box off a return air temperature. Well, that means that you may or may not get sufficient airflow through the duct. You may not have sufficient for the thermal fusers. So it was basically a misapplication, and we cited it, and they had to change the control sequence. Okay. Okay, so we have another district that is very high on bipolar ionization, air cleaning systems. And a lot of them are low-level ozone generators. And so the key here is they're saying we can save energy by reducing the amount of outside air because we're using bipolar ionization to clean our air, okay? And in their mind, they have dissociated that completely with CO2. So we actually, in schools, have gone in where they have this bipolar ionization in what is really densely occupied areas, and we've measured CO2 levels between 1,500 and 1,600 parts per million, and we're getting reports, the school district is getting reports of sleepy kids.
The designers opted for sleepy.
Yeah, and this gets back to Jim's comment about, well, it's better to be sleepy than moldy.
But we use UV systems here too in doing the same thing in our schools.
Yeah.
Have the same CO2 issues with that as well.
Okay.
A big issue that we deal with too is control sequences of operation, and there's a lot really, so we'll just touch on a few of them. But fixed operating schedules need to be established in conjunction with the energy management for the school system. So the worst thing that happens is you sit down with the controls contractor, you commission the system, and then the energy manager sits down behind you and changes all the schedules. Let's integrate that and decide how we're going to manage the school and set the schedules up with all the stakeholders in place. Sequences are incompatible. How many times have you gone to commission a dehumidification system, find out that the heating coil is not on the downstream side of the cooling coil? This type of thing happens over and over again. It's like the definition of insanity. Location of static pressure sensors, location of differential pressure sensors are big issues, particularly when you're rushing equipment onto the site. You got a 3-day operation window to do the installation, and so you stick your discharge air sensor or your static temperature pressure sensor like 2 feet from the discharge of the fan or something. The other one that we deal with is we're getting a lot of sustainability sequences of operation, which is good. But then we end up with sequences of operation that talk about discharge temperature reset, discharge static pressure reset, VAV positional minimums and maximums. And before long, you get into, well, what takes priority over what else? So when you're reviewing sequence of operation, that's, I think, the question you really need to bring paramount. Is it more important to do static pressure control first or temperature control first? Or how do you arrange the hierarchy? And this is stuff you can cover well up front during design review and when you do submittal review, so you don't get into arguments when you're trying to commission it and determine what it's really supposed to do. Fan cutout switches is a kind of a pet peeve of mine, and you know you always get current sensors if they can do it because it's a cheap way to do fan proof. But the problem is fan belt breaks, current switch makes, everybody's happy, but there's nothing going on. So critical systems really need to have, you know, flow proof in order to make sure that you know that you got proof of flow. Test and balance is a big issue on school projects again, because what's going to happen here is they're a lot like us. They're going to get about a month and a half scope of work condensed down into 10 days to get the balance done before the school starts. They're going to be working at night. They're not going to get cooperation from the controls contractor. You know, they're going to be mad at the janitor. You know, they're going to take it out on the principal's office. Who knows? But bottom line is we really need to help to make the tab contractors get integrated into these school projects, particularly when they're owner procured. We may give them the right documents, set them up for success. Most people want to succeed. We just need to help them to do that. And one of the big issues that I see on these projects is since they have to be done really quick, what the tab guy wants to do is he wants to just jack up the static pressure and just blow air out into the system, or the same thing with the distributed pumping. And they end up setting way too high differential pressure set points or static pressure set points because it guarantees them the airflow and the water flow so they can get in and out of the job. So basically, you know, the view could be, well, we're checking capacity and this proves that there's plenty of capacity, but you're really not balanced until you've taken that step of optimizing the set points, and particularly static pressure and hydronic differential pressure set points.
Okay. So that concludes our presentation today. If anybody's got any questions, I don't know if we've got any time or not.
We probably got a little, but probably not a lot of questions. Okay. Thanks a lot.
Thank you.